Curing activity is actually taking place on this pavement. In every engineering design, there is always a purpose. We have designed various type of slab. We have actually designed the solid slab. We designed the raised slab. We also designed the waffle slab. And then today we are going to be looking at zigzag waffle slab, which is this particular slab we are going to be designing. And so stay connected so we all tackle together both the challenges in designing this type of slab as we get started.
So here is the model we will be using for the design of the zigzag waffle slab. So stay connected, stick to this video till the end, and you will gain a lot of knowledge in this video, because in the course of this design of zigzag waffle slab, we will be facing some challenges which we are going to be discussing together on how to resolve it. So do not forget to drop your comment in the comment section. I was opportune to design a shopping mall using zigzag waffle slab, and as a structural engineer, when you are analyzing a zigzag waffle slab, you should expect to have the value for the support moment as well as the shear forces and the span moment. So this is what you are actually analyzing for. So in a situation where you analyze the structure using a structural software like Protastructure, and then there is no value generated for those parameters you actually analyze for, in that case, what will you do? So these are things we are going to be discussing in this video. So stick to the video till the end. Do not forget to like and subscribe as we get started. All right, so now we will proceed. Over here, you can see that at the first floor, I'm having a rib slab here, okay, at this first floor. So at the second floor, we are going to be having the zigzag waffle slab. So you will learn how to model it, analyze, and design successfully. Okay, so let's navigate to the first floor. So we move the grid line to Storey 2, just like this. Okay, then at this Storey 2, we get to the floor plan of the Storey 2, just like this. Okay, so we proceed to the modeling tab right there. So we use these options, rib, slab, options. Okay, so we have the dialog just like this. Okay, so we have the gen tab, we have the insert tab, we have the load tab in this rib slab dialog. Okay, so from the gen tab, we have over here the label of the rib, we have over here the type. Okay, so if you select in this drop down menu, you see prefabricated as well as the grillage. So you will understand all of this in this video. All right, so now for the width of the rib beam, we are going to be considering 150 millimeters. Then the depth of the rib beam is going to be 300 millimeters. The edge of slab, we leave it positive, and then the spacing of the rib beam, we are going to be considering 500 in this video. So this is the settings. All right, so at first, if you are using standard options in this type provisions, all right, and then you click right here, you are going to be having a kind of a rib slab. Okay, you'll be having a rib slab. All right, so we just place this, but we have not set the load. So you can come over to the load, so you can see the set width right there. Then for the additional dead load, you can click in this provision and use room. So this is 2.38 kilonewton per square meters assigned to additional dead load. Okay, for the slab design. Okay, for the imposed load, the purpose of this structure is residential, so we use 1.5 kilonewton per square meters. I can click on update so as to update the rib slab I've inserted already. Okay, so this is how to insert rib slab. Okay, there is another options here. We have the insertion tab. Okay, so if for instance I click in this insert transverse rib right here, okay, and I click now, you will see what happens? You can see a transverse rip right here. Okay, so that is the work updates options. All right, so I can uncheck here and click on update. Is up. Okay, if I select it and update, it's being placed successfully. All right, so I'm just trying to show you how to use most of these tabs successfully. So shortly we go into the zigzag waffle slab. Okay, so I come back to the gen and click in these provisions, and this is prefabricated rib. Okay, so if you want to create a waffle slab, you can always use the grillage option. So if I select on the grillage option now, and then I click in these provisions, this is a waffle slab, but this is not the zigzag waffle slab. All right, so having understood all of this, I will click on close, and then I will get rid of these slabs that I've just placed. I'll hold the control key to select multiple of it, click on the delete options, and I delete this. Okay, now we want to start to create the zigzag waffle slab. All right, so I'll select in this on this rib, right click, I'll use it property, or you can also get to the modeling tab and use this particular tab. Okay, so this will now require you to start the setting all over. Okay, so why I use the property here is because I wouldn't want to go ahead setting again and again. So I will select this, right click, and then click on it property, so I can have all the setting intact. Okay, so over here you see I have my loadings. Okay, so I will change that to 150 because this is what we're going to be using, and this provisions is going to be 300. Okay, just like this, and then here will be 500. All right, just like this. So we want to start to model the zigzag waffle slab, and we move straight away to these provisions where I have the type, which is standard. I'll change it to grillage. All right, then I come to the insert right here. The load, we have already set it right here. Then the insertion tab right there. So we have an rib angle. So now we want to give this waffle slab an angle. So once you incline a waffle slab, you are automatically designing for a zigzag waffle slab. All right, is that taken? So once you incline the ribs, okay, the rib beams that consist of the waffle slab, you are designing a zigzag waffle slab. So we are going to be inclining this at angle 35 degree, just like this. All right, so you see what happened. So I click in this panel, you can see. So the rib beams are now being inclined. So this is called zigzag waffle slab. We have modeled it now, so let's continue the modeling because we are going to be analyzing this, and then we'll be facing some challenges in the course of this analysis and design. So I will see how to resolve it successfully. So don't forget to drop your comment in the comment sections, and it will tell us why we're having these challenges and how to resolve these challenges. I will also provide a solution based on my own knowledge. So stay connected as we do this together. All right, so now I have successfully inserted my zigzag waffle slab. Okay, so I will click on save option to save this project. So at this point, if you are yet to like and comment in the comment sections, kindly do so. All right, so let us make progress. Now I will navigate to the 3D. So let's see it in 3D. So this is what we have. All right, at this level is the roof level. Okay, so we wouldn't have any structural slab here. Okay, so now we have the rib slab, and then we have the zigzag waffle slab. All right, good. We proceed to carry out the analysis of this slab. So we will carry out the global static analysis first, and then we will do the FE, which is the finite element analysis, successfully. All right, so I will navigate to the analysis tab, and then you see building analysis option. Okay, so I click on that. All right, so I have my dialog right here. I'll go straight away to the analysis tab, and then click on the building analysis. All right, so in the bash design options dialog, I wouldn't want to actually design any structural members. I will do that later. I proceed to building analysis. So we give the program some seconds to carry out this analysis successfully. All right, as you can see, building analysis is completed successfully, and then you see over here, relative story drift, certify limit in both directions. As you can see, click on the OK options, and then over here, we will close this dialog right now. Having analyzed the structure, we will also proceed to carry out the FE, you see, FE flow analysis. Okay, so you click on that tab. So now we have to select all of this. You see, we select all of these stories, so all will be actually analyzed successfully. Okay, or it will be analyzed simultaneously without doing it stories by story. Okay, so now I will include the upper stories, and then the stiffness factors for slab I will change it to 0.25. This you can see. Okay, so the slab slash raft shell elements is going to be 500 millimeters, 1000 millimeters maximum. Okay, then you can click here to edit the materials if you wish, but we are going by the already edited material. Okay, I click on the flow mesh and analysis. So we give the program some seconds to carry out this. So you can see it is existing FE model exists for this first floor. You can see over here, which is the story 3. So I click on yes options. Do you want to replace it? Yes. Okay. Let us replace that. So we analyze all the floors successfully. So this is the roof level. It is being analyzed successfully. So you don't have to click on this tab. Click on OK option, so it can proceed to the second story finite element analysis. So I click on OK. You can see this is the second floor. Okay, finite element analysis is done on the second floor. We go to the first floor, clicking on OK option. All right, so here is the first floor, which is the last floor, finite element analysis of the ribs. Okay, we click on the OK option. So this is completed. Now you can see over here, analysis is completed. Mind you, I am using Protastructure 2024 version for this design. Okay, so analysis is completed. I can click on the close option right here. All right, so we want to start to design. Since we have successfully analyzed, we will design. But before we design, we have to draw slab strips on this Zigzags Waffle Slab as well as the rib slab successfully. I'm at story 1, which is the rib slab story, so I will navigate to the 3D. And also, if you want to confirm that you have carried out the necessary analysis over here, where you are building analysis, you can see green check right there. FE floor analysis, you also see green check, meaning analysis is done successfully on this model. I'll navigate to the modeling tab and then slab strips options. Over here, we have 2 tabs. I have the general and the ST bar, so we'll be working on the general only. Okay, over here is a kind of a manual reinforcement activations, okay, which I always teach my masterclass student. So you can be one of our students. So let's just make progress. Okay, so now this is direction X and Y. So we are in direction X right now, and then this is the number of the strips. So over here, type analytical strip. No, we'll be using FE strips. Okay, so we are having a slab bounded by a beam, so we use the first options you can see over here. All right, then over here the analysis source is going to be FE floor analysis successfully. So we have boundary conditions out to out, which is the center one, bob to bob. Okay, is our boundary condition for now. So let's start to draw the slab strips. I click here, take my hand to this other side. I have to hold the control key to have a straight line. I click to have my strips drawn successfully, just like this, you can see. And you know, rib slab is a one-way slab, all right? Rib slab is a one-way slab, so we only have strips in the X directions. We are not going to have strips in the Y direction. So let's continue to draw our strips in the X directions. Make sure you have a straight line, strips, okay? Just like this, just like this. All right. So don't worry, by the time we carry out the design, you will actually see the challenges that I was talking about. Okay. So at this point, we are done with this. We will close this dialog right now. Navigate to the Storey 2, where we have the Zigzag Waffle Slab. You can see. Okay, so we click on the strips again, and then in the X directions, here we go. Everything, leave it for positive as we have set it before. So now you start to place the strips in these directions. I hold the control key to have a straight strips, just like this. I picked it again, and I clicked here. Over here, I clicked, and then in these panels, I also have the strips as well as this panel successfully, just like this. So that is it in the X directions. Zigzag Waffle Slab is actually designed two ways, all right? So we are going to be having another strips in the vertical or the Y direction. So I activate it right there, pick the first point, and then I will move my hand, and then I clicked here to have my strips in the Y directions, just like this. Okay, and as well I will have it here. All right, you can see we are done with our strips. So the next thing we'll be doing is to carry out the analysis of the strips. Okay, so for a structural engineer to run analysis on a zigzag waffle slab, what you are actually expecting, or what you are actually, analyzing for as a structural engineer, what you are actually analyzing a waffle slab for is for you to get your support moment, after which you get your shear forces and mid-span moment, or you can just call it span moment. Okay, so these are the three moments you are actually looking for, because that is what you are designing. Okay, you are designing the moment and as well as the shear forces. Okay, so now we will proceed to where we have the slab strips at Storey 2. Okay, I want to show you something here, so you have to be just pay attention. I will click on that rib slab, right click, and then you see over here I have rib slab analysis at Storey 2, which is the zigzag waffle slab that we have actually created. Okay, is what we are going to be analyzing now. So I click on this rib slab analysis. So I will analyze all the lines, okay, but not all the story, only this active story. I click on design. So let's wait some seconds to get the report. here we go. Okay, so you can see rib slab analysis result. Axis X5, Storey 2. You can see the input members right there. Okay, the height and the rest of that. Now come over to the next table 2. Table 2, we have the support moments, we have the shear forces, we have the span moment. Okay, so this is what we are actually analyzing for. We are analyzing for support moment, shear forces, and span moment. But right now, this does not give you any value. You can see we are having 0, 0, 0, 0, 0. So does it mean that the waffle slab is not properly designed? So that is a question that you have to also answer in the description of this video. What happened to this? Okay, let's try the slab at Storey 1, which is the rib slab. Okay, so you can see nothing, even axis X6 Storey 2. Okay, we have no value for the moment and shear forces. Okay, so even axis 7, no value for the moment and shear forces. Okay, which is what a structural engineer want to see, because this is what we actually design. Okay, but we don't have value for it. So what is the issue? All right, so let's close this, and then I close these options, and then I go to Storey 1. So I navigate to the rib at Storey 1. Okay, this one. So right click and then click on the rib slab analysis. Okay, I click on design right here. All right, here we go. So you see rib slab analysis result. Axis 1, Storey 1. Okay, so the first table, and then we have the support moment. You can see the value for the support moment, shear forces, as well as the span moment. We have value for this Storey, but for Storey 2, we did not have any value for the moment and shear forces. So what do you think is the cause of this? So this is the challenge I was facing actually, but we see to its end. Okay, continue to comment in the comment sections if you have idea on what is actually happening, that we did not have this value for the moment and shear forces at Storey 2. So you can see all the strips at this Storey has its moment and shear forces, which is the reason or what a structural engineer is actually looking for while carrying out analysis of a reinforced concrete slab of this kind. Okay, right now we close this, then we are going to close this as well. All right, so now we have successfully analyzed this. So we want to actually design. So designing is to actually reinforce the bending moment and shear forces. Okay, so now we navigate straight away to this design tab right here, and then we have rib beams. So if I click here, you can see that the design statute is showing red cross, meaning it is not designed. Now over here we have the Storey, we have the axis, we have Storey 1, okay, we have Storey 2. So Storey 1 is the Storey we have the rib slab, while Storey 2 is the Storey we have the zigzag waffle slab. Okay, so let's carry out the bash design and see if all of this will be designed successfully. I click on the bash design and then reselect all bars, okay, and calculate. Give it some second. The program is going to design this successfully. See, process is completed. So I click on the close option so you can see. What do you experience here? You will notice that the Storey 1, that we have moment and shear forces actually designed and give us a kind of U ratio, okay, and then a green check. While the Storey 2, that we wouldn't get the moment and shear forces also designed, but the statute did not change. The statute did not change, and then we have U ratio as well. You can see. Okay, so what is the cause of this? If I double click on this to interact it, you can see that I'm almost having everything designed successfully. I'm with 2T10, 2T10, 2T10 top and bottom for the rib, okay, for the rib beams. All right, so I click on the OK. So let's check this. Okay, for Storey 2, I click on interactive design. You see what I have. Design is not valid. Do you want to update rebars? Yes option. So rebars is also updated. So this has actually generated rebars for us. Okay, but after analysis, there was no moment and there was also no shear forces, value generated. But we are having everything. The rebar has been designed successfully based on the zero moment and shear forces. So what do you think could be the cause, and how do you see this design? Is it trusted? Can you work with it that you have designed and then you did not see your span moment, you did not see your shear forces, you understand? And then the design was carried out and then you have your reinforcement. Do you trust this design? Okay, so what do you think is the problem with these issues that we are just, what do you think is the solutions of this issue that you are just encountering right away? Click on the OK option. Now, I want to show you some other things that actually marvels me as well. So I will close this dialog. Here we go. I will take you to the drawings and reports tab. Now we want to be creating drawings over here. See rib, beams, elevations. I click on it. Over here, I will create first drawing for Storey 1. I click on it. Okay. So this will show us the drawings, the detailed reinforcement drawings right away. You can see, zoom closely, you can see what we have. So this is the rib beams, sections. You can see we have two at the tensions as well as the compression successfully. Okay, you can see for the slab or the rib slab that you actually had all the necessary analysis and results. Okay, so I get back here and then I click on X again and then I choose Storey 2 where we have the Zigzag Waffle Slab. Okay, I click on the OK option. Here we also have detailed drawings. Okay, we also have detailed drawings here based on that design that we wouldn't see all our shear forces at moment. Okay, after analysis. So this is the Zigzag Waffle Slab detail. So the program actually did not show us I will navigate to that Storey again. The program did not show us our span moment, did not show us the shear forces after analysis, but it generated reinforcement. You can see we're having all of this 0, 0, 0, 0, 0. Okay, does it mean that it is infinitesimal, like it is too small that it cannot be displaced right here? Because we really need this value. They are very, very important. Okay, so what do you think about this? So this is the challenges I actually faced while I was designing the Zigzag Waffle Slab. So the same challenges is also faced when you design the normal waffle slab as well. But on the rib slab, you have everything designed successfully. So what do you think about this? For me, I would say that maybe the program actually mixing up the value of the shear forces as well as the moment successfully. That is why it was not displayed. And then it also affected the statute of design. Okay, the statute of design from the design tab and then rib beams, you can see the statute of design, and then the U ratio have actually changed to 0, so you have to redesign this because we reanalyzed the floor. That is why the U ratio actually changed. So you see the U ratio is back, but we are still having a red crossed check right here. You can see what we are having. Okay, so what do you think about this design? and what is the issues with this. How do you resolve these kind of issues? Okay, so you can drop your suggestion in the comment sections. Then in the next video we will fully discuss about what and how to resolve this kind of challenges successfully. Stay connected. Don't forget to like, do not forget to subscribe, for it is possible that you have learned one or two things in this video. Okay, we stop here. Thank you for staying through the video.